Hi everyone, this video is going over the next part of the Quadratics 2 notes. This section of the notes involves the use of the quadratic formula. The quadratic formula is a formula that has been come up with. It is a formula that is given to you in the formula sheet, so you do not have to remember it. I will link you a video with the quadratic formula song, which is how I always remember it. I was shown it in school and I've just remembered it ever since, but you don't actually need to remember it, so if you don't, then don't worry, it is given in your formula sheet. That is it there in the grey box. And how we use it is, so we have our numbers A, B and C coming from our quadratic equation. Normally if we had our quadratic equation like we had in the previous lessons examples, we could factorise first, get it into two brackets, set them equal to 0 and then find out our two values of x. Sometimes we cannot factorise the quadratic equation and therefore we use the quadratic formula instead. If in an exam or a test the question wanted you to use the quadratic formula, it would always tell you to round your answer. When we're doing the factorising method, we generally end up with whole numbers or fractions, and therefore we never have to actually round our answers. When we're doing the quadratic formula method, we end up with big long decimal numbers, so we generally are asked to round them, and they're given in calculator papers because generally, again, we use a calculator for them. Okay, so quadratic formula is in that grey box there. We are going to start by writing down A, B and C for each question. Now we don't need to do any calculations with the A, B and C on their own, we just have to substitute them into the formula. So we'll remember that A is in front of the x squared, B is in front of the x, and C is the number with no x's attached to it. So for example 1, A is 1, B is -6, and C is 7. Once we have those three numbers, we can use the quadratic formula. So x is -b plus or minus the square root b squared minus 4ac all over 2a. Okay. Now the substitution and then the further calculations are the bits in these questions that require the most amount of work. You know, you're not asked to really do much thinking with these questions, especially if it's just asking you to use the quadratic formula and there's no maybe extras added on. But for this one, we have to substitute in the numbers on the left hand side. So -b is negative whatever your number is for b. My number for b is -6. -6 is +6. So I replaced b, -b with +6. b squared is -6 squared minus 4 times a is 1 times b is 7. That is all over 2 times 1. So that's our substitution step. The next step I would ask you to do is to tidy this up a little bit and then do your calculations in the calculator. So 6 plus or minus, and then I'm going to try and get a number for underneath that square root. -6 squared is the +36. If you're putting this in your calculator, make sure that you put brackets around the -6 before you square it. Okay, so that's 36 minus 4 times 1 times 7. 4 times 1 times 7 is 28. So 36 take away 28 gives me a square root of 8, and 2 times 1 gives me 2 on the bottom. Now you remember from the previous lessons that we always ended up with two values of x. So this expression here is x equals this expression. The way we get our two values, well, one value is the expression with a plus symbol on the top, or the second value of x is our expression with a negative symbol, or with the minus symbol. So this plus minus up the top there is a generally commonly used symbol in maths. It just means plus or minus. So plus minus 5 means we can either use plus or minus 5 in that calculation. Both of those numbers are relevant. So once we've split those terms up into 1 plus and 1 minus, we can put that in the calculator. So I would say 6 plus the square root of 8, and then I would say divide by 2, and I get 4.4 to 1 decimal place. Let's see if that's what I was asked to round it to. It'll always tell you. Yep, just 1 decimal place I was asked to round this to. Then I do 6 minus the square root of 8, hit equals, divide that by 2, and I get 1.6 to 1 decimal place. So therefore, x is either 4.4 or x is 1.6. Now, as you know, those are large, long decimal numbers. We couldn't calculate that through factorisation, because we'd have x minus 4.4 and or x plus 1.58 and so on. So that's why we have to use this formula to calculate those two values. And again, this to 1 decimal place tells me that I have to use the quadratic formula. So we're always looking out for that when we're doing solving quadratic equations. Okay, the next one here, we are given a quadratic equation again. We can find our values of a, b and c and substitute them into the formula. So a is 3, b is 4 and c is negative 9. X then, for our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, well b is 4, so it's negative 4 plus or minus the square root of 4 squared minus 4 times a is 3 and 9, c is negative 9. And then that has to be all over 2 times 3. Again, I'll tidy up that bit underneath the square root before I split it up into plus and minus. So 4 squared is 16. Okay, so if I was to do this out at the side here, this calculation would be 16 take away, so 4 times 3 times negative 9 is negative 108. That means it's 16 plus 108, which is 124. So actually underneath the square root is 124 all over 2 times 3, which is 6. So as I said, the calculations here, like known to use the formula, etc., isn't the hard bit. It's the actual like rearranging, substituting in, making it into a form that you can put it in the calculator. Okay. Now, if we were to put this straight into the calculator, so 4 squared minus 4 times 3 times, and I put the negative 9 in brackets, I do get the number 124. So as long as you put brackets around your negatives, you should be able to get the 124, or the number that it should be underneath the square root coming out at the end. So once we have this all tidied up, then we split up our two values of x. One value of x is negative 4 plus 124 all over 6. And the second value of x is negative 4 minus root 124 all over 6. So I would do minus 4, put that in brackets, plus root 124, hit equals, then hit divide by 6, and we get 1.2 for the first value of x, and the second value of x has to be, so negative 4 in brackets again, minus square root 124, divide by 6 equals negative 2.5. Now remember, we did get negative values previously. That is perfectly fine to have negative values as our values for the quadratic formula as well. Again, I was asked to round to 1 decimal place, so that told me to use the quadratic formula, and I rounded the decimals to 1 decimal place at the end. Now, just like before with the factorising method, we can also have our equations displayed to us in this form, where we don't have 0 on the right hand side. That box up here lets us know that we must rearrange to have 0 on the right hand side, otherwise the quadratic formula does not apply. Once we've done that, then we can apply the quadratic formula. So when I subtract 3 from both sides of this equation, I will get 2x squared minus 5x minus 4 equals 0. So that was minus 1, take away another 3 to move the 3 over to the left hand side, which gave me that expression. Now that I have 0 on the right hand side, I can use the quadratic formula with a as 2, b as negative 5 and c as negative 4. So I'm writing this out every time. Obviously, when you're doing loads of these at once, you may not wish to write it out every single time, but I am giving you, as we're doing these separately, different examples, different pages and so on, I'm writing it out every time. So negative b is negative of your number b, so negative of negative 5 is positive 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times 2 times negative 4 for the c, all over 2 times 2 is our a. So when putting this in the calculator, I am going to, for the bottom underneath the square root, I'm going to put that in the calculator just now and make it negative 5 squared, putting the negative 5 in brackets, squared on the outside of the bracket, minus 4 times 2 times, and then the negative 4 at the end, put that in a bracket, and we should get the number 57. 2 times 2 is 4 on the bottom of the fraction, and therefore I can split this up. One value of x is 5 plus root 57 all over 4, or the other value of x is 5 minus root 57 all over 4. Again, put a top line in the calculator and then get your answer and divide it by 4. So 5 plus root 57 equals, divide by 4 equals 3.14. I wanted 2 decimal places this time. And next one, 5 take away root 57 equals, divide by 4 equals 0.64 as my final answer for that one. Okay, those two there being my two values then of x for this expression. The main thing with this example was that we had to make sure that we rearranged that top so we had 0 on one side of the equation. Now there's only one past paper question on this within the notes. Again, we have to try and create the expression. So we're trying to create this expression in part A of the question. That's what we're trying to end up with. Just like we did with the past paper questions and the ones where we had to create and then solve the equation during Thursday's lesson. Okay, so write down an expression for the length of the card in terms of x. Now the length is, as you can see, the height of the card. Since we know that from here to here is 13, and we know that both edges are x, they're both the same width, so both of them are x, that means that the expression for the length has to be x plus 13 plus x, so two lots of x's, and 13. So I've got x here, that bit's x, this bit's 13, and this bit is also x, so two lots of x and also 13 as well. Now we're also told, so if we read back up to the question to try and get part I, the rectangular frame is placed on a rectangular piece of card. So the picture is the white bit and the card is the bit around the outside, okay, the full size. There's a border X centimetres wide on all sides of the picture. Now we're told the card, the area of the card is 270 square centimetres. Okay, so what we can say then is that length times breadth equals area. So that will mean that the length, which we know is 2x plus 13, times, additionally, we can also multiply, we also find the width of the card, which is 2 x's on either side, plus 9. And that is all equal to the area, which is 270. So we're going to have to do a bit of obviously multiplying out these brackets and then rearranging to try and create the equation in part 2 of question A. So I'm going to take that down. I think I might have the space enough to do it down there. No, I'll be able to fit it up here. So that'll give me 4x squared plus 18x plus 26x plus 13 times 9. This will be on a calculator paper, so we can use a calculator for it. 117, and that all equals 270. Okay, I'm just trying to squash that in there just so I've got enough space to do the quadratic formula in a little bit. I need to take away 270 from both sides and collect the x's. So 4x squared plus, that is 30, 44x. And let's just make sure 117 take 270 does give me minus 153. And that's all equal to 0. So I've taken away 170 from both sides at that last step. Okay, now that was what I was trying to get for part 2 of the question. Just like we saw with the factorising examples, you can also have, it gave you what answer it wanted you to get. You just had to try and prove that you could get to that with the algebra and the rearranging and so on. Okay. So for this part C of the question, part B, sorry, we are looking to calculate x, which is the width of the border, and we have to give our answer correct to 1 decimal place. So you could try and factorise this expression, 4x squared plus 44x minus 153. You'll realise it doesn't factorise, but also you're asked for it to 1 decimal place. So we know then that we have to use the quadratic formula. If we couldn't do part 2 of this question, then we could easily have still done part B because we are given the formula in part 2. So you can still get 4 marks. Even if you can't get the first 3 marks for part A, you can still get the 4 marks for doing the quadratic formula in part B. So A, B and C. A is 4, B is 44 and C is negative 153, coming from that formula in part 2. We are using the quadratic formula, which is negative b plus or minus the square root b squared minus 4ac all over 2a. Negative b is negative 44 plus or minus the square root of 44 squared minus 4 times negative 153. That's all over 2 times a, which is 4. Right, so let's again get a number for underneath that square root. Pop that in the calculator. 44 squared, take away 4 times in brackets negative 153. You've got to put that negative in brackets. A lot of your calculators won't work if you don't put it into brackets. It won't give you a correct answer out, so make sure you do. Right, so that is 4 383 all over 8. Okay, so one x value then, one possible, is negative 44 plus root 4383 all over 8. And the other possible value is negative 44 minus root 4383 all over 8. Now, let's get this in the calculator. Negative 44, pop it into brackets, plus the square root of 4383 equals, divide by 8 equals 1 decimal place, I think so, yep, 2.8 for this possible value. Or negative 44, take away root 4383 equals, divide that by 8 is equal to negative 13.8. Now, as I said before, with the context questions, we do have to make sure that our possible answers make sense. We are told that x is a width of the frame, or the border round the picture. So a width is a length, which means it has to be positive. So therefore, our final answer is x equals 2.8, and we have to discard the negative answer. Okay, we don't have to write why we discard that negative, we just have to say that we're discarding that negative. You have to say the word discard, it's going away, it's not being used. Okay, and our final answer there is x equals 2.8. Okay, that's us for the quadratic formula. I'm going to give you, for period 1 on Friday's lesson, I'm going to give you the general question, so you'll just be given an equation and you'll have to use the quadratic formula on it. And then for the second period of the double, I'll give you some questions that look like this one as well. So some where you have to create that formula first. But we'll spend most of the time looking at just using the formula first of all. Okay, right, so your instructions will be on the Teams page with specific pages and questions to do. Please refer to that for the questions to complete for Friday's lesson. Okay, thank you everyone.